Now, least to greatest, and we're talking about decimal numbers. So I want to introduce just one basic comparison to get you started. And if you're having trouble with this, and I'm writing these on the screen, you should write them down too. Okay? By the 5th grade, you guys need to know that. If the teacher's taking time to write it down, you should too. Least to greatest with decimals. Let's compare these two. 8.4 and 8.04. Okay? Question? Yes. So if we look at these two numbers, 8.4 and 8.04, which one is bigger? Julian?
8.4.
8.4. How do you know?
The 0 is meaning that is a tenth.
Okay. So let's look at the same place value here and compare, because I think that's what he's talking about. This one's got a larger number here. They both have 8s, so we can't use the 8 to compare. So then we're going to go to the next place value, which is tenth. Is that what you said? Tenths. All right, so that's the first way. We're going to look at the same place value and compare. So 4 is bigger than 0. That's why this number would be bigger. Can I show you one other strategy? You can always put a 0 after the number when we're on the right side of the decimal and look at this 8.40 compared to 8.4. So now, when you think about it this way, what number is bigger? 40 or 4? 40 is clearly bigger. So it makes sense either way when you tack a 0 on the end, because it helps you see, well, they both have 2 decimal places here, 2 decimal places here. 40 is definitely more than 4, so I'm finished now, right? Can you do this with whole numbers?
Yes.
No. When you add a 0 onto the end, right, 6 does not equal 60. You can't just tack a 0 on the end. But after the decimal, that's when this is okay, because it doesn't change the decimal values. Okay? So that's the strategy that I would advise you to use. Stick a 0 on the end to help you have the same number of digits. Yes, Mackenzie? No, you don't have to do that. Okay? So that's one strategy. So then when we come across problems, let me copy one over from Delta Math here. Let's see, ordering. What is it? Order level 2. So let me write these down. We have 9.46, 9.309, 9.5, 9.43. And I know you can't see these yet, at least not what I'm writing. And 9.306. All right. So let's see if you can read those clearly enough. What do they all have in common? They all have decimals, but in terms of their value, they all have what at the front? A 9. So if they all have it in common, we can't use that to tell a difference. So we go to the next place value, okay? So here's what I'm going to do. I'm going to highlight the first number, the first decimal place, I guess we'll say. And Julian's already said it, but let's see if anybody else knows it. What is that place value called? Tenths. Not tens, but tenths. Tenths, okay? And you should write this one down because I'm actually going into the next lesson this way, okay? So you'll notice this one's got a 4, 3, 5, 4, 4, 3. So which one of those is clearly going to be the largest?
5.
The one with the 5. Okay? That's going to be my largest. But before I go any further, do you think it would be helpful if we made them all have the same number of decimal places?
Yeah.
You should say yes, because it will. So, what's the most number of decimal places any one of these has? Well, this one only has 2. This one has 3. 1, 2, 3, 3. So guess what? The easiest thing to do is going to make them all have 3 decimal places. Now, I know we've already done 9.5, but I'm going to put the numbers in here anyway. So I could put 2 zeros at the end and make it 9.500. Okay? 50 cents is the same as 5 dimes. Agreed? 2 quarters? All right. So, I've already got that one finished. But here's what I want to do. 9.46, I can make that a 0. That one's already got 3 decimal places. This one's 4.3, so we'll put a 0 there. The others all have 3. Once you do this, you're then able to just compare 3-digit numbers now. So what's the next largest 3-digit number? I have 306, 494, 430, 309, 460. What is the largest one?
9494.
494. So it would be this one. So 9.494. Then what's the next largest one out of 306, 430, 309, 460? 460. So I have 9.460. What's the biggest one left now? 430. And then 309 and then 306. 9.309, 9.306. So what I've done here is given you a strategy. If you are struggling with this problem set, make them all have the same number of decimal places. The ones that need more decimal places, tack a 0 on the end because it does not change the value of the decimal. Okay? Did that help anybody?
Yes.
All right. How do we say the number in words? Okay? So, we're going to take some notes first. Put that down, put your pencil up. The same way that we have place value for whole numbers, and I'm only going to do the first 3 for right now because that's all this lesson is going to ask of you. Let's think, what is in this position for a number? I think you're going to say it.
1.
Ones. Okay, what about that one? Tens.
100.
Hundreds, okay? And we know hundreds is larger than tens, which is larger than ones. That's how we read numbers. Now, that has not changed. And you had to work with that a little bit on, put candy up, guys. You had to work with that a little bit on that delta math. But we're going to do the right side of the decimal, and some of you already know it. Did you learn this in the 4th grade?
No.
You don't? All right. Wonderful. So we have tenths. Okay? Or I want you to think about something, okay? Because a lot of times money is a great way to have an analogy. We're taking notes, so you should have your notebooks out, guys. You're losing the game if you're not paying attention and writing down what's on the screen. Dimes. Dimes go in this position, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have 3 dimes, you know that there's going to be a 3 here for 30 cents. Okay? Eli, question?
Can we use notes on the test?
No. The purpose of notes is to learn the material, have something to go back over, and also to more deeply put it into your brain, okay? When you write something down, it's more than just seeing and hearing, okay? All right, so the next one
Is 100.
Hundredth. Now, it's very important you pay attention to the last 3 letters there. THS. Hundredth means 1 out of 100. So this position is kind of like how many pennies you have, right? How many pennies do you have?
1,000.
Okay? And then the last one, if you pay attention, you look at the pattern, it's what, Julian?
1,000.
Thousands. Good. But you'll notice all of these have THS at the end because they're less than 1. They're a part of a whole. They're not a whole. Whereas these were whole numbers. Okay? These are decimal parts or fractions of the whole number. All right. So if that's the names we're expected to use, then let's write down a few examples. 12.5. While we say it that way so many times when we're working with it, that's actually not the appropriate mathematical phrase. We're going to say 12 and. Now, you might have heard me say when we pronounce words, you don't say and unless there's something after the decimal. 5. And we look at what position is the 5 in.
5/10.
So it's going to be 5/10. Okay? Maybe it would be helpful. Huh? You can take the whole card if you need it, Miss Thompson. What's that, Julian?
Which is also 5/10 is also equal to 1/2.
All right, it is equal to 1/2. That's true. We're not going to go there yet, but I like where your head's at. All right, so what if I wrote this? Because sometimes it's helpful to have the same number of decimal places. What if I did this? We'd say 12 and what? 12 and 50, 50 hundredths, okay? Are those equal?
Yep.
Yeah. 5 dimes is equal to 50.
Hundreds. So you get 500,000.
Oh, taking it even further. 5 dimes, 50 cents. Yes, Mackenzie? Yes. When I'm indicating what we're going to say. Answer yourself, guys. All right. Why did I capitalize and? What does that correspond with? It is important. So the and is like the decimal. And then everything that's after and is after the decimal. Good. Okay. Let's move on to a different number.
90.3.
Okay. So, yep, I know informally we just say 2.37. But we need to be able to say the actual words. 2 and 37 hundredths. And I think if you wrote some notes down from lesson 67, you might be able to write this as a mixed number. Right? So 2 and 37 hundredths. 2, well, hang on a sec. 2 and, let's write that as a mixed number. If you know how to say it, 37 hundredths, that's going to mean 37 over 100. That can be really helpful if you're struggling with the place value after the decimal. Okay, you write this down, Daniel? You got it? The next part? Okay, I only get so many minutes with you. 2 and 37 hundredths. Okay, well, let's keep some of the same numbers, but let's put them in different spots. Yes, Anna? You need a Band-Aid or something? Is it like bad? Just don't squeeze it on anybody and we'll get you one before lunch. All right, 2 and 37 hundredths. Let's compare this next one really closely, folks. Example 68.3, 2.307. Now, same number, different number, bigger, smaller. What is it? Now, Colin, you seem to have some success with that one. Bigger or smaller than the last one?
Smaller.
Smaller. How'd you get that?
Because 2, 3, and then 7, and 0.
All right, so he stopped there. He looked immediately. He's comparing the same place value. This one's got a 7 in the hundredths. This one's got a 0. Which one's bigger, 7 or 0?
7, 8.
7 is bigger. It's not how many digits it has. It's where they have the largest digits. Okay? So, how do we say this? Once we acknowledge, yep, it's going to be smaller. It's 2 and... Now, I'm just going to write the fraction here because I think... Well, no, I'll write it in words too. 300... Whoops. 7 thousandths. Okay? 307 thousandths. Let's write it as a mixed number to clarify. Okay, so 2 and 307 over 1,000. So getting from here to here, I think, is really important because I think this is easier to read, but it's a reminder of how you read the decimal version of it, right? Questions about these three examples? All right, so if we'll take the last few minutes here, get your book out and turn to page 346. I don't want to see 8.9. What I want to see is 8 and 9/10. Letter B, 24 and, we'll just write this, 42 hundredths. For the sake of time, I'm just going to write that number there. Letter C, I got a few questions on. Letter C doesn't have a whole number part, so we don't have to write 0 and. You could, it wouldn't be wrong, but we're just going to skip to the end and write 125 thousandths. Okay? If you write the 0, it's okay. It doesn't change the value. Colin, make sure you're checking yours. Letter D, 10 and 75 thousandths. Okay? Use digits to write the number. So 25 and 52 hundredths. So 25.52. Here's the reason why you don't want to just write 25.52 up here in these problems. You've got to know what this means. If we were to write that as a mixed number, that can be extremely helpful. 25 and 52 over 100. 30 and 1/10. So that's going to be 30.1. 7 and 89 hundredths. Letter H, 234 thousandths. Do you have a whole number in letter H? No. So 234 over 1,000, or what you guys probably wrote, if you got it right, 0.234. Now, why do I keep talking? Colin, have a seat, buddy. I'm not done yet. Why do I keep talking about the mixed number, or the fraction in this case? I want you to make sure you are aware of something. If I were to type 234 divided by 1,000, look at what I get. 0.234. Okay? I don't know if you're amazed or being sarcastic. But I need you guys. Shh. Can you do what again? So all I did was type in this fraction, because a fraction is what operation? Division. 234 divided by 1,000. 0.234.
Can you do 0.234 times 1,000?
It's
Interesting.